Yes, so Maciej, the floor is yours.
Thank you very much. I'm Maciej Malecki. I'm dialing here from Wrocław in Poland, Europe, not Netherlands, sadly, another one. And I would like to present you the tool that I have been developing for the last 2 years, I would say, with short breaks. Of course, I'm also doing different things. And this is the retro build tool. I mean, the name is evolving, but I like the retro build tool because it has RBT acronym and it's okay. Because this is my first time, thank you that I have a possibility to present myself and my production here. So I will just provide you a couple of information about me. So I'm here because I am a Commodore 64 user in the given time frames, so in the 90s, and since 2016. I'm so-called the retro user. And yeah, we are in Poland a little bit late with this kind of equipment. So we started in 90, and I think that the Commodore 8-bit machines were prolonged in Poland, quite used in the late period of its original life. And what is most important, I learned to code on this machine. And now I'm working as a software developer. I'm just using different languages. Yeah. And also, my dream, I mean, people wanted to be the firefighter. I wanted to author a computer game for Commodore 64. And by some reason, I didn't manage to do it in 90s. So I'm doing it now. Yeah. And this tool basically is evolving because I have some needs, yeah, in my development work. And of course, it is now quite fun to be a developer for 8-bit machines because there is this brilliant idea of cross development, which makes it a very convenient. I have also discovered the Kick assembler, which is a very nice dialect, I would say the modern one. And I'm basically working for Kick assembler, and the tool I'm going to present is currently supporting Kick assembler only, but it will be also extended in the future. A lot of tools, nice IDEs are available. And there is one thing that is missing. Yeah, there is one thing that is missing for me as a professional developer. Yeah, so I'm missing a continuous integration system. And a continuous integration system is a nice idea so that you can automate your development process. So you don't need to really click anything or use some, I don't know, user interfaces to do the building of your software, but you can just run a script and this will do everything from the beginning to the very end automatically. So this is a very important point. The second important point is that you fail fast, which means that as fast because you will be able to run this tool frequently because it is automated, it's cheap to run, you can actually get the failure quite fast. So you can get the feedback quite fast. Yeah. So my favorite approach is that each time I push something to the Git, the build starts somewhere, and then if I screw up, I got an email, yeah, that doesn't work. Yeah. So this is basically that I have made. Of course, I know that in Commodore community, it's quite popular to use the make as a automation, and I decided that make is not enough for me. I mean, of course, I would say it's not that easily portable to different machines. I mean, this is a native tool for Linux and Unix systems. For Windows, this usually does not work out of the box. This is a funny argument. It's aging, yeah, for somebody who is writing software for 40 years old architecture. But I would say there are better, more modern replacements for Make, and I will use one of it. It's called Gradle. The biggest problem with Make and Makefiles is that it requires some, I would say, extra work to set up a new project. So I would say normally you just take one of the Makefiles from your old project and you just adjust it to the new needs. And I really hate this approach, yeah, because if you have like 10 active projects, and I have a couple, and then you want to update all of them, then you will have a problem because you have, you know, several customization adjustments spread around. And yeah, I wanted to solve this problem. And I also tracked down the origin of this problem. And the origin is the problem is that the Makefile says how to do the things. And I would like to have something that will allow me just to say what I want to do. Yeah, I don't want to write how this should be done. This should be built into the tool. Yeah. Okay, so I will make a short demo right now. I will make a short demo. I will show you a very trivial kick assembler program which just sets up the border color to cyan. And a dry joke now is that the software engineer in 21st century requires an external library to change the border in a Commodore 64, because you see, I have imported some magic library, and you know, I'm just using this constant from that library. Yeah, but I would, this is what I want to show you. I'm using the Gradle build system. I just wrote this plugin here. So you just have to specify the plugin with its version. If you want a new features, you just need to change the version here. And in a retro project, you basically specify the dialect and the dialect version. Here, I'm specifying also the libraries. I will remove it later because this is, I mean, for the basic thing, it is not really necessary. So you can just run the tool like this. Yeah. I hope it will take 4 seconds. Yeah. It's written in Java, so yeah, it requires now 8 seconds. And I can actually run this, what I have built, and it will be really impressive, you know. This is, I mean, the border is changed. What I wanted to show you, I mean, you don't really need this, and you don't really want to do this kind of stuff, yeah, because you can just, this is the only cell I remember. Yeah, this will probably also work, and then our build can be simplified. We can just remove this. So you really need like 5 lines of code, yeah, to start building. And you don't have to say which file to build. It will automatically find it and build it. Yeah, this will also work. Okay, let's make a little bit more sophisticated example. So I will just switch the branch. I will just switch the branch. Yeah, and in this sophisticated example, I'm also using those libraries. Now I will maybe elaborate it more. And I just want to, you know, reconfigure the memory to use the RAM, IO RAM, and I would like to unpack some data. I will just move some data blocks somewhere, and I will just configure the VIC2. So I will be just using the multicolor bitmap mode. So you probably know what I'm going to do. I would like to display a picture, but I, honestly speaking, I need this picture. The build will now fail, of course. The build will now fail because I have no picture. The build will now fail. So I don't know, you probably know the Harpad. You probably know this tool. This has been recently, the Harpad port has been recently enriched with a bitmap bow support. And there is a brilliant thing. You can import the PNG file. You can import the PNG file here. You can select the target format, and here it is. And if we will uncompress it, we will get just 1,000 characters of our bitmap. So I would normally now, from this Harpad thing, I would just go here and I would export the binaries, all this kind of stuff. But I will do something different. I will just save this file, and this file is the native format. It is a native format for Harpad. I will just save it in my project. Yes, I save it. I mean, it of course fails to compile. Now we'll try to compile it. Yeah. Now it works, and I will try to run the PRG. Yeah, I'm running the PRG. Here it is. What has happened? Yeah, the my build tool has been enriched by support of Harpad export. You don't have to do the export from Harpad manually. You can just code it here in this pre-process section. So you can specify, just take the input file, bomba CTM, and generate following output files. There is some metadata, some hard set colors and screen colors. This is all we need. Yeah, so this is working. And if we just go there, everything compiles now. Yeah, everything compiles now perfectly. One thing about the libraries, because I'm a professional programmer, so I always create libraries. So the thing with libraries is that, yeah, on a GitHub, I have some library repositories. Yeah, and here there are some kick assembler sources that you can include. So the tool I have developed have a possibility to download those libraries automatically. Yeah, actually there is a bug because it always downloads it. This is can be probably much faster. It downloads the library, it stores somewhere here in the dependencies, and then you can include it. It also downloads the kick assembler with the appropriate version. So you don't even need to have a kick assembler installed. So you just say what you want to do, and you don't have to care about how to want to do this. Okay, so I will just close it for now. I will just show you, because I mean, this is all simple, but as I said, as Jim said, because of the lockdown, I also started to develop a computer game because I always wanted to do this. I always wanted to do this. And you see this computer game, I mean, I decided it is using the, it is using the tile system and the color per tile stuff, the hard set and so on. And it has the maps, yeah? And there are 5 levels in the single map. So what I was doing before, I was just, manually selecting this, and I was using this export function to export the selection. This is really annoying, yeah? But the tool that I have developed, I mean, this tool now, you can in this tool actually select the portions of the maps by specifying the coordinates of 2 edges, and this export will be done automatically. We can take a look, yeah? I was also annoyed with the goat tracker export, so I have developed the wrapper over this goat tracker relocator, so you can also trigger it from there, yeah? If a goat tracker, you have to specify the address and it will all work. Yeah, let's just run it. Let's just run it. There will be no sound, but the game rose. Yeah, this is how it works. Yeah, cool stuff. Okay, last thing I would like to show you, because I'm running out of time. The last thing is that, as I said, we have an automation now, but how about the feedback? Yeah, so I'm using the CI system called Circle CI, which is running somewhere on the cloud. And it just works like this. It just integrates with my GitHub account, and it looks for new commits. Anytime I will push something, it will run exactly the same build on the cloud. And for instance, it can create a GitHub release for me automatically, or it will fail and send me an email. Yeah? The thing is that, of course, in order to build with my tool, you also sometimes require the Vice emulator or Goat tracker or Exomizer. So I have prepared the Docker image, which is the, let's say the disk image of the Linux operating system with all those tools already orchestrated. So you can use it, yeah? You can use it, and I will just show you how this works. And this is really the last thing I would like to show you, because I don't know if you know that you can write the unit tests for kick assembler programs. And you see this on the screen, yeah? I have this copy large mem forward subroutine. I can test, I wrote 2 tests for them, because the library, I mean, you cannot easily run it to check whether it runs. But if you can use this 64 spec library for writing tests, then you can just go there and you can run it. Let's run it. Yeah, you can run it and you have a feedback, yeah? To show you that this is really working, I will just break this code. I will just remove STA. I will change it to LDA. This time I run the test. It will be all red. Yeah, it is all red. But I would say it is again very annoying. I have multiple those spec files here to go through and run everything and check whether this is working or not. So this is this build script for my library project. You see, it is also very compact. There is only one additional library, which is 64 spec from Michał Taszycki. And I will just go there and I will not run it locally. I will just push my error. So it fails. I will just push it to the repository, yeah, to the GitHub, and just let's go here to the Circle CI and see what you see. I have pushed, now it is running somewhere in the cloud, yeah, and after some time we will see it is failing. Yeah. In the meantime, I will just show the last two slides. The one, there is a roadmap. I'm planning to add exomizer crunching thing afterwards, maybe some support from some other assemblers as well. And there is the link. Yeah, there is the link to the GitHub repository. There is also a documentation. There is also a link to the documentation, to the manual, which is, I would say, I'm very proud of it. It's quite comprehensive already. Let's just take a look at the pipeline. You see, it has failed. If I will just go there, and expand it, yeah, then I see 2 of 29 tests are failing. This is why the build is red. Yeah? Fail fast. Great. Do we have any questions?
Let me see in the chat if there is anything. Bigger font. Okay, maybe I took a bit too late. I guess
bigger. Oh, sorry. I was already making it bigger. Yeah. Sorry.
Oh, I see. Nice comment. Just whoa. Maybe I had a question. So you say, okay, there you are sharing now the link on GitHub.
Yep.
Nice. You say there is documentation as well. So I suppose there is a kind of quick.
There is exactly, here is the link to the documentation on the GitHub, and there is the document. Yeah, so I think I have described every aspect that is already there, together with some concepts, high-level concepts. How does it work? Also here, there is a project, I think that it is public, and in this project, there is like a backlog. No, I don't want this.
But so if you want to use it with another editor on, for example, here I see also you're on Windows. But if you want to do it to use it on a Linux machine or something, it
should use everywhere. It should use everywhere, because all thing you need is a Java virtual machine version 11 or better, and you don't even need to install the Gradle on your machine, because usually there is something which is called the Gradle wrapper, which means that there is a bat and a bash file. So, I mean, it can download the Gradle for you locally. So it's even that easy. If you want to create your own builds, then probably it will make sense to install the Gradle. I mean, it is completely free tool. Just go there, and there is probably somewhere like a download section. Everything is described in the documentation, because I know that it might be a little bit tricky for somebody who is not working with Java software engineering on a daily basis, but it's really simple. Yeah. I also plan in the future to create a standalone tool, so the Gradle will no longer be needed. Yeah. So there will be just a command line tool you can install, and it will have its own file format. But this is like the future for the maybe next year or next 2 years. Yeah.
Okay. And if someone comes and say, I would like to have this or that extra functionality, you recommend them just to fork it, or are you happy to have co-workers?
I'm happy to have a co-workers. Of course, the tool is written in Kotlin, which is a very nice programming language. It is also a great opportunity to learn this language. And I mean, it's open source. Currently, I'm developing it myself, and I'm the only driver for the features. But you can again, as you see, there is a backlog. You can create your own features. You can just contact me, and yeah, I will see. I have already, like, I know that I need to crunch. I need to do this kind of stuff. But I got already a request to do some kick-C support or milfork support. We'll see. Milfork and kick-C is easy peasy because it's all Java. Native tools is a different story.
I would say thanks a lot, Maciej. I don't know if there are more questions, but I don't see any for the moment. I see just nice comments. But if there are more questions coming, people can put them in the chat. I will stop the recording now. Are you sure you want to stop?